So in our last video, we were looking at these two sets, A union C minus B, and we looked at A minus B union C, and we looked at the Venn diagrams, and based on the Venn diagrams, we said that the first set is a subset of the second one. So now what I want us to do is actually prove this. So let's prove this right here. So the first thing we're going to do is we're going to essentially outline the proof. So let's start there. So remember how we show things are subsets. You're going to start with an element over here. So I'm going to, my start for my proof. So my start of my proof would be X is in A union C minus B. And then I'm going to leave some space. Hopefully we're going to leave enough space. And then the end of the proof will be that X is in this other side here. X is in A minus B union C. So let's go one line before this. If X is in this union, it means that X is either in A minus B or X is in C. So this is what I need to get to. So let's go back to the start, and we've got to fill in this kind of gap here from the start to the end. All right, so let's fill in that gap. Okay, if X is in A union C minus B, what does that mean? That means X is in A union C and it's not in B. That's just the definition of set difference. So now let's take this A union C. Well, from here I know that either X is in A or X is in C and X is not in B. So what I'm going to do is, I see this or here, what I'm going to have to do is I'm going to have to split off into cases. So my case 1, the first possibility, is that X is in A. And case 2 will be the opposite of that. X is not in A. So let's look here. If X is in A, well, we said, if you look back here, that X is not in B, right? So what do I have? I have X is in A and X is not in B. Well, that's exactly what it means to be in A minus B, which is one of the two things I needed. Right? I needed one of those two things to happen, and I got that X was in A minus B. So we're done with the first case. Let's look at the second case. Well, X is not in A, but what did I say earlier? If you look back here, that X is in A or X is in C. And we're also assuming here that X is not in A. Right? This is from here. Well, if it's in A or C, but I know it's not in A, by process of elimination, it has to be in C. So this means that X is in C, which again was one of the two things I needed to happen to get my end result. It either needed to be in A minus B or it needed to be in C. I got that it was in C. So this is kind of the rough outline of what the proof would be. So now let's take this and write a formal proof. So look at the start of your outline. You're going to take an X in A union C minus B. So you're going to let X be in the universal set such that X is in A union C minus B. Then go back and look at my outline again. Well, then I had this second line here. So then X is in A union C and X is not in B. So what was our third line in our outline? X was in A or X is in C. X is in A or X is in C, and X is not in B. And from here, if you go back to our outline, that's where we split up into the two cases. So next in our proof, we'll say we will consider two cases. And those two cases were X is in A or X is not in A. So we're going to, in our proof now, focus in on case one. Case one, we supposed, if you look back, we supposed X was in A. And what did we say in case one? X is in A and it's not in B. So I'm going to say, since we also have X is not in B, we have X is in A and X is not in B, thus X was in A minus B. And that was the end of case one. And then we had case two now, where we supposed that X was not in A. But since X is in A or X is in C, but we knew that X was not in A, that meant that X had to have been in C. So here's where we're going to sum up what we learned from our two cases. So in case one, X was in A minus B, and in case two, X was in C. So either X is in A minus B or X was in C, which giving X is in A minus B union C. So now we've kind of completed the proof, and what did we show? Hence, or therefore, we've shown that A union C minus B is a subset of A minus B union C. And we've completed the proof now. We've shown that these two sets are subsets. Here, the first one is a subset of the second one.